What would actually happen if Jupiter lost its entire atmosphere? Let's find it out in Universe Sandbox. Somewhere out in the cosmos, there might be a planet right now that astronomers call the conical planets. Those are completely exposed cores of gas giants that orbited so close to their stars that radiation stripped away their entire hydrogen-helium atmosphere. The term was coined in 2003, describing the theoretical fate of the hot Jupiters. Worth mentioning that no such object has ever been definitely confirmed yet. It remains a purely theoretical category of planets. So we strip roughly this much kilograms of hydrogen and helium from Jupiter, which is 96% of its total mass. What we find is surprisingly uncertain even from scientists. The Juno probe, by precisely measuring Jupiter's gravitational field, revealed that its core isn't a sharply defined ball of rock, but something researchers called a fuzzy core, extending through as much as half the planet's radius, with rocky material dissolved into a surrounding metallic hydrogen, with no clear boundaries. Estimates of that core mass range from 7 to 25 Earth's masses, depending on the model. We'll take the middle value for the purpose of this video, so it's 12 Earth masses. After removing the gas envelope, what's left is a planet with a radius of about 8,850 kilometers. It's composed mainly of water, methane and ammoniac ice, mixed with rock and metal, with a metallic ball of iron and nickel at the very center, almost identical to Earth's core. Due to the planet's drastic mass change, the moons aren't able to stay on their current orbits. But here's the interesting part. Surface gravity on our new planet actually increases. Currently it's 25 meters per square second, including the atmosphere, and without the atmosphere it's 61 meters per square second. So where does the increase come from? The answer to this puzzle lies in the radius and the gravity equation itself. The radius dropped by nearly a factor of 8, while the mass dropped by only a factor of 25. So once you divide by the square of the radius in the gravitational equation, you end up with a far larger value for the acceleration itself. By stripping Jupiter of its atmosphere, we likely stumble onto another fascinating discovery. Unlike on Earth, the magnetic field is generated by the molten iron in its core. Jupiter's magnetic field forms in a completely different place, in the deep layers of metallic hydrogen about 10,000 kilometers below the upper atmosphere, where pressure of the million atmospheres squeezes hydrogen so hard so it becomes electrically conductive liquid metal. And it's circulations of a metallic hydrogen that generates a field 10 times stronger than Earth's and a magnetosphere stretching out past the orbit of Saturn. But the layers of the metallic hydrogen is part of the envelope we just removed, not part of the rocky core. By stripping away its gaseous mantle, we simultaneously destroy the entire dynamo mechanism. The exposed ice rock core, even though it contains a small metallic ball of iron and nickel, resembling the Earth's core, would generate a magnetic field which is incomparably weaker.